Okay, guys, today we're going to start chapter 11, which is about acids and bases. I would like you to have a couple of things out. Well, really just the guided notes today. So please have out your chapter 11 guided notes. And let's fill out this the guided notes as we go through these slides. I've got a picture up here that reminds me of acids and bases. They're solutions. And an acid or a base, if you look at this beaker right here, can you tell me whether that's an acid or a base just by looking at it?
Definitely.
You can't. There's no way you can tell just by looking at a solution whether it is acidic or basic. So that's why they're putting what in it here? This little test strip, right? This little test strip. It's litmus paper. By the change in the color, you'll be able to tell whether it's acidic or basic. We've also got pH strips that you guys will use in lab, and you dip it in there and you notice the color that it goes to, you can line it up to its pH, which will tell you whether it's an acid or a base. Speaking of pH, there's a pH scale. It goes from 0 to 14. Right in the middle is 7, that's neutral. Okay, we're going to talk about the pH scale throughout this chapter. We're also going to do a lab. This is called a titration. They're trying to figure out the concentration of an acid or a base. And we'll do that and figure out how to determine the concentration there with the titration. So, kind of some of the things that we're going to be doing in this chapter. So let's get into it. Please have your notes out, your chapter 11 guided notes. So a solution. We learned about solutions a couple of chapters ago. A solution is made of two parts. What are they? Solute and a solvent. Well, solutions can be classified as either being neutral, acidic, or basic. All solutions can be either neutral, acidic, or basic. The pH scale is going to help us determine whether it's neutral, acidic, or basic. The pH scale goes from 0 to 14. And it measures the amount of hydrogen ions and hydroxide ions in the solution. Now I'm going to be talking about these ions all chapter. The hydrogen ion is H+. Okay? H+ makes things acidic. So if it's got a lot of H+, hydrogen ions, it's going to be an acidic solution. What if it has more hydroxide ions? Well, the OH-, which is hydroxide, it's one of our polyatomic ions, makes things basic. Okay? A pH of 7 is neutral. So if you test the pH and it's 7, that's neutral. It's neither acidic nor basic. But if the pH is under 7, what is it, guys? It's going to be acidic. And if the pH is above 7, it's what? It's basic. So, hot quiz. What if you test the solution and it has a pH of 2? Would it be acidic, basic, or neutral? It's acidic. Yeah, if it's under 7, so 2 would be under 7, it would be acidic. What if you tested and it was 12?
Basic.
Yeah, then it would be above 7 is basic. Okay. What does pH mean? Well, we're going to see these letters a lot in this chapter. pH represents French words, pouvoir hydrogen, which means hydrogen power. So pH literally means hydrogen power. And that's because if you put more H+ in a solution, what happens? It becomes more acidic. And that's what you're measuring is the pH. All right. On the top of your guided notes there, I would like you to write this in. Okay, I didn't include this in your notes, but I want you to draw in the pH scale. So let's draw something like this. Okay, and let's go from 0 to 14. What's right in the middle of 0 and 14? 7. So maybe at the top of that page, let's do this pH scale here. Right in the middle is 7. Okay, that's neutral. Now let's label, where would the acids, where is an acidic solution? Where would that be on the pH scale? Below 7, 7, or above 7? Below 7. So let's write acidic from 0 to 7. And where should we write basic? Yeah, above 7. Okay. Now, if I asked you, where do you think the weak acids or the strong acids should be put? If we're right by 7, which is neutral, let's say we were at 6. Is that a weak or a strong acid? That's weak. Okay. And what if it was 0 or 1? Yeah, this is the strong acids. Okay, now let's go to the bases. Where's the weak bases going to be found? Well, right by 7. So let's write in weak, right by 7, that's neutral. And the strong bases would be where? Yeah, by 13, 14, right? And let's put neutral in for 7. Give me an example of something, a substance that has a pH of 7. Water. Okay, water is neutral, H2O. Okay, very good. So I want to introduce acids, and I've got 7 properties that I would like you to know for acids. Number 1, acids produce H plus ions in water. So if it's got a lot of H plus in water, it's going to be an acid. Also, some chemistry textbooks write H plus as H3O plus. So in your notes next to this one, I want you to write this. H plus equals H3O plus. They are the same thing. Some chemistry textbooks use H plus, and that's what I like to write. Some, though, will write H3O plus. H3O plus is called the hydronium ion. But they mean the same thing. It's just a water molecule with a hydrogen attached to it. So it's got one more hydrogen, H3O plus. Okay, but just realize they mean the same thing. Okay, the second property of acids is that they taste sour. If you've ever bit into a lemon, that's what we're talking about here. Lemons are acidic, basic, or neutral. They're acidic, and they taste sour for that reason. It's the acid that makes them sour. Okay, number 3, we saw this before class with the penny. Acids will corrode metals, which means they dissolve metals. If you have a car, you've got to take care of the car battery. If it gets old and it starts leaking, it's filled with sulfuric acid, it can corrode the battery terminals and the cables that are attached to it. Could it get to the point where your battery terminals and the cables that are attached to it are dissolved and corroded so much that they break? Sure, and so you've got to make sure you take care of your car battery because of that reason. Number 4, acids are electrolyte solutions. So if you put an acid in a solution, will it be able to conduct electricity? Yes. Remember that demonstration we did with the light bulb? Did the light bulb light up with just water? No. If you put an acid in, would it light up?
Yes.
Yeah, if you took that water and you put some acid in it, it would start to light up. Number 5, acids react with bases to form salt and water. So acids will react with bases to form a salt and water. What if I did have an acid spill on the ground? What's the best thing you could put on it?
Water.
Okay, water is one thing that you could put on it. But what would neutralize it even faster than water?
A base.
A base. Because if you react an acid with a base, you form salt and water. And what's the pH of water? 7. So you would meet in the middle in terms of the pH scale right at 7. And that neutralizes it. Okay, number 6. Acids have a pH value that is less than 7. So acids on the pH scale is less than 7. And finally, acids will turn blue litmus paper to red. So if you remember that first slide of this chapter, there was a person dipping a piece of litmus paper into that beaker. Well, if the blue litmus paper turns red, it's an acid. So how do you remember that? Blue to red is acid. Kind of rhymes. Hopefully that helps you remember if it goes from blue to red, it's an acid. Okay, now we're going to do the same thing for properties of bases. I've got 7 of them. Number 1 property of a base is that they produce hydroxide ions in water. So if it's got more OH minus, it's going to be a basic solution. They taste bitter. One example of this, one common example of a base would be soap. If you've ever got soap in your mouth, it tastes very bitter, and the reason for that is it's got a base in the soap. Number 3, they are electrolyte solutions. If you put a base or hydroxide ion into water, it turns it into an electrolyte solution, which means it can conduct electricity. Bases, if you get them on your hands or your fingers, they feel soapy and slippery. Well, in fact, that's what soap is made out of, a base. And so it kind of feels slimy, very slippery. Number 5, bases will react with acids to form salt and water. So if I had a spill of a basic solution, what's the fastest way I could neutralize it? Put an acid on it. It would form salt and water. Okay. Number 6, the pH of a basic solution is greater than 7. Yeah, from 7 to 14. And then finally, number 7, a basic solution will turn red litmus paper to blue. And how I remember this is if it goes to blue, that is basic. Basic and blue start with a B, so that just helps me remember. If it changes to the color blue, it's going to be basic. Now I wanted to show you some common acids and bases so you get a kind of an idea of what we're talking about here. So this is the pH scale. Again, it goes from 0 to 14. Let's just start right in the middle. What substance has a pH of 7 that we know about?
Water.
Pure water. pH of 7. It's neutral. Now let's start with the acids, guys. Some common acids. I want you to look. What are these substances right here? Fruits. Fruits are acidic. In fact, they have citric acid in it, which makes them acidic. So when you're thinking about common acids, think about fruits. Bananas, tomatoes, grapes, the lemon. Okay, and then you got a stomach here. Stomach acid helps aid in the digestion of the food you eat. Is acidic. It's very strong. In fact, it's pH of 1. How many of you have ever had heartburn? Okay, what is heartburn? Does it have anything to do with your heart? Nothing to do with the heart. What is heartburn then? Yeah, it's when the stomach acid comes back up into this tube right here. What do we call the tube that goes to the stomach?
Esophagus.
The esophagus. So sometimes the stomach acid from your stomach can come back up this esophagus, and the esophagus lining is not made to withstand low pH. And so that acid here will come up into your esophagus and it starts to irritate the lining of your esophagus, and that's what heartburn is. That's what you're feeling. It's very uncomfortable. So, what do you take if you have heartburn? What do you take if you have heartburn? Seriously. No! What do you take?
Ammonia.
Tums. So, what must be in Tums if it's helping you with your heartburn? It must be a base. And that's really what it is. It's a tablet that has a high pH, It's a very basic, and it goes into your stomach, which neutralizes that stomach acid and kind of calms the stomach, and it doesn't allow the stomach acid to burn your esophagus as much. So that's how it helps with the heartburn. Okay, very good. So you think acids, what are you thinking? What are some common acids that we know of? Fruits, and also the stomach. Milk is also a very weak acid. It's pH of 6, a very weak acid. Okay, now let's go to the bases, some common bases. And what you're going to notice here, what do you notice about these substances?
They're all deadly.
They're all cleaning agents. They're all used in cleaning stuff. So we've got soap, we've got ammonia, bleach, and oven cleaner. How many of you guys have ever cleaned your oven with that spray? If you get close to that, it just makes you cough almost immediately. It's very strong, and it reacts with your respiratory system very fast. Anyway, think about common bases are cleaning agents. At the end of the year, we're going to make soap, a bar of soap. You're going to make it on your own, and then you're going to test the pH of it. It has a very high pH. It's very basic. Eggs or baking soda, kind of a weak base there at 8 and 9. So, yeah, when you think of common acids or bases, hopefully now you have some kind of reference that will help you remember what a common acid or base is. Okay, let's delve deeper into this acid and base idea here. All water solutions contain hydrogen ions and hydroxide ions. So all water solutions contain hydrogen ions and hydroxide ions. I didn't put this in the book, but I want you to write this in the margins, at the top or the bottom. Last chapter we learned about reversible reactions. The reactants go to the products, but the products can also come back to the reactants. I want you to write a reversible reaction for me. Okay, we're going to start with water, H2O, and it's going to decompose. What does that mean? It means it breaks apart, but it's reversible. So water can decompose into H plus and OH minus. So water can decompose into the hydrogen ion and the hydroxide ion. Well, water is at what pH? 7. So water has the pH of 7. So at the pH of 7, you have equal amounts of hydrogen ion and hydroxide ion. You have one hydrogen ion and one hydroxide ion. But what happens when you start to mess? And what if you started to put in more hydrogen ion? Or what if you started to put in more hydroxide ion? We'll see what happens. Okay, an acidic solution contains more hydrogen ions. So acidic solutions contain more hydrogen ions. So if you dumped in more hydrogen ions, what's going to happen to the pH? It's going to get more acidic. What's going to happen to the pH though? It's going to go down. So I want you to write this. H plus, if you put in more H plus, the pH is going to go down. It's kind of a trick that they love to ask questions about that. If you put in more H plus, the pH is actually going to go down because H plus makes things acidic. Now let's talk about bases. A basic solution contains more hydroxide ions. It contains more hydroxide. So if you put in a whole bunch of hydroxide, so if I have hydroxide ions here, and I put in a whole bunch, what's going to happen to the pH, guys? It is also going to do what? It's also going to go up because it makes it more basic, and that's a pH that's greater than 7. Okay, so the usual solvent for acids and bases is what? Is water. In fact, we call water the universal solvent. It's very good at dissolving all kinds of solutes. Water produces equal number of hydrogen and hydroxide ions in a process called self-ionization. So if you look at this, water plus water goes to H3O plus hydroxide. Remember, some chemistry textbooks write H plus as what? H3O plus. So when it says H3O plus here, couldn't it say H plus? Yeah, and that's what happens. One water molecule will grab a hydrogen from the other one, and it becomes H3O plus, or H plus, and it leaves hydroxide. This is a very important slide point that I would like to make. Okay, so let's look up here. The hydrogen ion, the hydronium ion, H3O plus, means the same thing as H plus. Now let's look at this picture right here. This is the pH scale. So at neutral, what's neutral on the pH scale? 7. Let's say it becomes acidic. It goes down to what? 0. Let's say it becomes basic. It goes up to what? 14. Now, right at 7, what can you say about the concentration of H plus and OH minus?
Equal.
They're equal to each other. We have equal red and equal blue. But let's go to pH of 0. Now all of it is what? H plus ions. Very high concentration of H plus, no hydroxide. So we're at a pH of 0. So H plus makes things acidic. Now at a pH of 14, now what is it? It's all hydroxide, so it's a basic solution. So OH minus makes things basic. All right, this is a self-ionization of water. We have 2 water molecules here. One of them is going to grab the hydrogen of the other water molecule and pull it off. So now we have this H3O plus, or as I like to just call it, H plus. And what does that leave? Well, it leaves OH minus. Well, this is water. So these are equal. You have one molecule of H plus and one of OH minus, so the pH is 7. Now let's look at the definition for an acid and a base. This is going to be very important for the rest of the lesson. An acid is a substance that produces H plus in water. So if it's an acid, it's going to have H plus in water. But this might be a better definition. An acid is a proton donor. An acid is a proton donor. Guys, what does it mean to be a donor? That means you give. Yeah, if you donate money, what are you doing? You're giving money. Well, if this is a proton donor, you're going to give H plus away. So that's what acids do. They give away the H plus. Now let's contrast that to what a base is. A base is a substance that produces hydroxide ions in water. That's one definition. But this one might be a better one. Okay, please put a star by this one. A base is a proton acceptor. What's an acceptor do? Yeah, it takes, right? It takes that substance. So if a base is a proton acceptor, it's taking the H plus. Okay, so an acid is a proton donor. A base is a proton acceptor. Now, some of you might have already realized this, but I've been calling H plus a proton. Here's why. H plus, it stands for the hydrogen atom, but it's lost its only electron. It only has one electron and it lost it. So now it's positive because there's only one proton there. There's no neutrons in hydrogen. So hydrogen, this H plus really is just a proton. So a lot of people call H plus a proton. So just realize that. If you see H plus and it's called a proton, that's what it means. Same thing. All right, I've got a bunch of practice problems. In fact, there's 8 of them that are going to follow. I want you to be able to identify an acid and a base in a chemical equation. And I think we can do that if we practice a little bit. So let's go through this. Practice problem number 1, it says, in the following chemical reaction, identify the acid and base from the reactant side. That's going to be important. The reactants side. What side of the chemical equation are the reactants on? The left side. So we're going to be looking at the left side. Remember, though, acids donate the H+, and bases will accept it. So that's how we're going to really identify it. So this is our first one. Let's go through it. Here's how I would approach a problem like this. It says from the reactant side. So let's just make sure we're looking at the left side here. One of these substances is an acid and the other one is a base. Your job is to determine which one's which. It can be complicated. So let me show you how I do it. If you look here at HCl on the left side, guys, notice what happens to the Cl on the right side? What happened to it? It lost what? It lost the H. What's another way of saying that? Did it donate it or did it accept the hydrogen? This is the donor. It donated the H+. Well, obviously that means that this substance took it. What's another way of saying that? It accepted it. It accepted the hydrogen. Now let's make sure that actually occurred. It was NH3. It became, on the product side, what? NH4. Did it accept a hydrogen, guys? It did, and it became NH4. This one donated it and became Cl-. So now let's go back to this definition. Acids donate H+. Which one's our acid? HCl. Which one is our base? NH3. Now, I hesitate to tell you this, but it's a general rule. It doesn't work all of the time. But if the molecule starts with an H, most of the time it's going to be an acid if it starts with an H. If it has OH in it somewhere, an OH minus, most of the time it's going to be a base. That doesn't work every time. You should always go back to this definition of an acid and a base and look at whether it's accepting or donating the hydrogen ion. Okay, let's go to practice problem number 2 and see if you guys can get this. Same question. I want you to identify the acid and the base from the reactant side. So we're just looking at the left side here. Remember, acids donate the H+, bases will accept it. If you're watching the video, please hit pause. You try to identify which one's the acid and which one's the base. Once you have your answer, hit play and see if you got it right. Okay, so hopefully at this point you have an answer. But let me go through and show you how I would approach this problem, okay? So this one's a little bit more difficult. If you look here, we've got sodium hydroxide, NaOH. If you look to the right side, we don't really see OH anywhere. So I'm going to kind of skip this one and come to this reactant, HCN. If you look to the right side, that's going to give us our clue, the product side. If you see CN is right here, but it's not with H anymore. So what happened to this H right here? Did it donate it or did it accept it? A hydrogen ion.
Donated.
It donated it. So this is our donor because, and here's why. It must have given away this hydrogen to become, it doesn't have a hydrogen over here. It becomes sodium CN, sodium cyanide. So that one donated the hydrogen. That means this must be our acceptor. But let's make sure. What we're saying is happening here, guys, is that the HCN is donating its hydrogen to sodium hydroxide. What do you get if you take hydrogen plus OH? One hydrogen plus an OH. What do you get if we added all these together, guys? What does that look like? What did we form over here? We formed water. And that's what's happening. This HCN is donating the hydrogen ion to the sodium hydroxide, which becomes water. Well, that means that the sodium's got to find another partner, and it went with the CN. So when they both switch partners, what kind of chemical reaction is that? Single or double replacement? Double. All of these acid-base reactions are going to be double replacement. So they both switch partners. You'll look at that next time and see if you can't notice that. All right, now let's answer the question, which ones are acid? Acids do what? Donate. So our donor here was HCN. Our base, obviously the other one, it's the acceptor. So NaOH, sodium hydroxide. And that worked perfect with our general rule. If it starts with an H, it's going to be a what? An acid. If it has hydroxide in it somewhere, it's going to be a base. But that doesn't work all the time. I'll show you. Okay, I've got a bunch more. Stick with me. I promise if you stay with me and try these on your own, you're going to figure this out. Practice problem number 3, same story. I want you to tell me which one's the acid, which one's the base from the reactant side. If you're watching the video, please hit pause. Please get an answer on your own. Once you do have your own answer, hit play and see if you got it right. Okay, guys, let's see if you got it right. Let's look at this. We start with AlPO4, which is aluminum phosphate. Now let's find the phosphate over here. Here's phosphate, and here was the phosphate. But now look at the product side. This is going to give you the clue. Does it have more or less hydrogen on it? On the product side. It's got more. It's got 3 hydrogens there. On the reactant side, it didn't have any. So is it donating or accepting hydrogens? Accepting. This one's accepting. Now, obviously, this is our donor, but let's make sure. Okay? It was HNO3. Now it's become AlNO3. Did it donate these hydrogens then? Absolutely, because it doesn't have it over here. It donated all of these hydrogens over here. Okay, so our donor is the acid. So HNO3 is the acid. And our base will be the aluminum phosphate. Just curious, how many of you guys got that one right? Okay, very good. Stay with me, I promise we'll get this. Practice problem number 4 is the same story. I want you to tell me which one's the acid, which one's the base from the reactant side. Again, please hit pause on your video and try it on your own first. Okay, hopefully you have the answer by now. Let's see how you would do this one. Let's just start here with this reactant, HCO3. Well, it became, on the product side, H2CO3. So is it donating or is it accepting hydrogens? It must have accepted hydrogens. So that's our acceptor. Our HCl must be our donor, but let's make sure. It became just Cl, so is it donating this hydrogen? Sure, it's donating it, and now it's just becoming chlorine. So our acids is donating, so the HCl is the acid, that's hydrochloric acid, and the base would be this HCO3 minus. How many of you guys got that one right? Pretty good. Okay, number 5 is same story. I want you to tell me which one out of the reactants is an acid and which one is a base. If you're watching the video, please hit pause right now. Try this one on your own, and then once you have your answer, hit play, see if you got it right. Okay, let's see how you did with this one. Here's how I would approach this problem. We have H2CO3. Let's try and find the CO3 on the right side. Well, there it is, but it's got no hydrogens anymore. It's Li2CO3. So what's happening to the hydrogens here, guys? Are they being donated or accepted? What's happening with the hydrogens right here? If it's becoming Li2CO3, they're giving them away. So this one's donating. This must be our donor. That means, by process of elimination, this one is our acceptor. But let's make sure. It was LiOH, now it's water. So what's happening is these hydrogens are coming over to the hydroxide. Again, the H plus the OH makes water, so this is definitely accepting the hydrogens. And there we go. Our acid then is the donor, since acids donate. And our base will be the lithium hydroxide. And again, that follows our general rule. If it starts with an H, it's going to be the acid. If it has hydroxide in it anywhere, that's going to be your base. Practice problem number 6 is the same story. I want you to tell me which one's the acid and which one is the base from the reactants. So please take a second. If you're watching the video, please hit pause. Try this one on your own first, and then once you have your answer, hit play. See if you got it right. Okay, let's see how you did. This one, if we look right here, is NH4. We have 4 hydrogens. If we look at what it became on the product side, now it's NH3. So did it donate or did it accept the hydrogen? Yeah, it gave one away because it got less. So this is our donor. It gave a hydrogen away. That means one of these hydrogens comes over here, and the water must be the acceptor. But let's make sure. It was H2O. Now over on the right side is H3O. So this one is definitely accepting a hydrogen. So the donor is our acid. So our acid in this case is NH4 plus. And our base was the H2O. Now you might be thinking to yourself, wait a minute. Water is not a base. Water is pH of 7. But in this example, the water molecule is accepting a hydrogen ion, which by definition makes it a base. Okay, I've got 2 more practice problems. Hopefully you're kind of getting the hang of this by now. Let's go to practice problem number 7. Same story. I want you to tell me which one's the acid and which one is the base from the reactant side. So please hit pause, try it, see if you can't get your answer. Once you do, hit play and see if you got it right. Okay, let's see how you guys did with this one. If I look here, I'm starting with C2O4. Let's try and find C2O4 on the product side. Well, there it is, but it's got a hydrogen with it. So did this molecule here accept or donate an H+? It accepted a hydrogen because it became HC2O4. So it must have accepted a hydrogen. That by definition or by process of elimination makes this one the donor. But let's make sure. It was HC2H3O2. Now it's missing that hydrogen at the beginning. So this is the donor. It gave the hydrogen to the other molecule. So now we just got to remember that acids donate the H+. So we go to the donor. There's our acid. Okay, our base accepts H+. So our base is going to be the C2O4 minus 2. Okay, very good. Last practice problem of the video. Same story. I want you to identify which one's the acid, which one's the base. Please try it. Once you have your answer, so hit pause right now, and once you have your answer, then hit play and see if you got it right. Okay, if we look at this molecule, it's HPO4. If we try and find the PO4 on the product side, it's right here. But now, how many hydrogens does it have? It's got 2. On the left side, the reactant side, it only had 1. So is this one accepting or donating an H+? It's accepting. Again, because it was 1 here, it's got to accept another one to become H2PO4. That means this one is our donor, but let's make sure. H2O, if it's donating, it's losing one of the hydrogens, and it becomes OH minus. So that does make sense. Now let's go back to our definitions. Acids donate the H plus. So our acid in this case is H2O, and our base would be HPO4 minus 2. Again, you might be thinking to yourself, wait a minute. Water, it's not an acid. That's pH of 7. But by definition, acids donate the H plus, and in this case, it is donating its hydrogen to another molecule. So that would be, by definition, an acid. All right, that's it for the lesson today. So hopefully that right now you have a better idea of what an acid is, all the properties of acids. You understand some common acids, the fruits. And hopefully you understand and have a better idea of what a base is. A base, cleaning agents. Hopefully you understand the pH scale. It goes from 0 to 14. 7 right in the middle is neutral. Below 7 is what? Acidic. Above 7 is basic. And hopefully you are able to identify an acid and a base based on this definition, that acids will donate the H plus, bases will accept an H plus, and you could tell me, out of the reactants, which one would be the acid and which one would be the base. And hopefully this video helped.